Hello everyone, this is Vikram and welcome to my channel. In this video, we will see what is Atlantis and how to use Atlantis for Terraform pull request automation. So which is basically GitOps for infrastructure as code using Terraform. So what is the meaning of this is you can maintain your Terraform code in SCM tools like GitHub, and you can modify your infrastructure code directly in the GitHub and raise a PR. But how do you review this PR? So if you have any Jenkins connected to your GitHub through webhook, basically Jenkins can clone this branch from where you created this PR, and then it can run Terraform plan or apply. But again, if you want to see the plan or apply output, you need to go to the Jenkins console output. But in case of Atlantis, so as soon as you raise a PR with your infrastructure changes in the GitHub, Atlantis will read your basically your branch. It will do Terraform plan or Terraform apply depending upon your requirement. But this plan and apply output will be directly committed back to your pull request as a pull request comment, so that you don't have to go to Atlantis UI and see plan or apply output. You can see them inside your GitHub PR screen itself. So that is the advantage of using Atlantis. So you can do a lot of things. You can just say, run the plan. So Atlantis can run Terraform plan for you, and you can also say apply. Then Atlantis can apply the infrastructure for you. But everything is committed back to your pull request. So you don't have to go to other tools to see the output. You can directly see them in the PR itself. So in this video, we'll mainly concentrate on understanding Atlantis, some basic configurations, setting up Atlantis as Kubernetes pod. For this, we'll see how to create an EKS cluster in AWS, and then also understand the Atlantis architecture, and then how do you connect Atlantis and GitHub. So we are going to do the initial setup and perform a simple change in GitHub repository, so Atlantis can take your changes and it can run plan or apply again. It all depends upon the command that you give. Probably in the next session, we'll see more configuration changes for Atlantis in the next video. So before understanding what is Atlantis, let's see what is infrastructure as code. So we know that we can create infrastructure in multiple ways. You can use any automation tools like Ansible, or write some scripts like shell scripts or Python scripts that can consume your cloud APIs for creating the infrastructure. Of course, you can also go to Cloud Console and directly create these infrastructure like virtual machines, databases, load balancer, etc., directly from the UI itself. But for doing this, it will take a lot of time, and you cannot easily reproduce the similar setup in case if you want to redo it across various environments. So what is this infrastructure as code is, you define the entire infrastructure in the form of a code. So your entire infrastructure is now codified. It can be any infrastructure across various cloud platforms. So you have the complete infrastructure defined as a code. Now using tools like Terraform that can read this IAC code, and it can actually provision your infrastructure. So instead of manually doing it, so which will be hard to reproduce, so we use code. Since code, we can use the same code across multiple environments, so you can be sure that the similar kind of setup will be, similar kind of infrastructure will be set up across various environments, because you now have the configuration in the form of a code. So this is IAC. So this is basically a Terraform code that is creating two resources. One is, it is actually creating an AWS Keeper resource inside AWS, and also it is creating an AWS EC2 instance. Now you can see this is entirely the Terraform code. Of course, some values are hard coded, like instance type, the AMI ID are hard coded, but you can also make it generic with uses of Terraform variables. But since you have the entire infrastructure defined in the form of a code, I can use the same code to provision infrastructure across multiple regions or multiple AWS accounts. And I can be rest assured that I'll get the similar setup across all these environments. Now, how do I use this IAC code? So let's say I have the IAC code, that is Terraform code. But how do I create the infrastructure? So there are multiple ways. I can run the Terraform commands directly in my local machine. Let's say I have the Terraform code in my local machine, and also I have Terraform installed in my local machine. So what I can do is I can simply run some Terraform commands, so that will talk to your cloud provider APIs and create the infrastructure for me. I can also do that, using any CI/CD tools like Jenkins. So that is also there, but we'll go to that later. So let's see, what are the disadvantages if you directly run your infrastructure code from your local machine, that is without having GitOps in place. So first is lack of version control. Let's say you have the Terraform code with you. Now you're not sharing it with anyone, so which means there is no version control. You're basically not maintaining it any version control tools like GitHub. So which means you don't have track of all the changes. You have the code, you can create the infrastructure, but you don't have the version control. The next thing is inconsistent environments. Okay, so you have the code locally, it is not being shared across multiple people because it is not being maintained in any SCM tool. So which can result in inconsistent environments because you might be changing the code in your own way. Someone might change the similar code in a different way. So this will lead to inconsistent environments. The other one is error prone, because you have the code, but who is going to review that code? Okay, you made some changes, so now those changes are to be implemented, but there is no one to basically review your changes. Then this would lead to error prone because uh, you know you're not basically getting the changes reviewed. The other thing is poor auditability and compliance, because you are actually maintaining it locally, so there is no one to audit that, and also no one to check the compliance. Difficult in disaster recovery. Okay, so let's say you have a code, you set up the initial infrastructure, now you made some changes to the infrastructure, but that infrastructure is not created properly. Then how do you roll back the changes? You don't have the previous files with you because you're not version controlling them. So now going back to the previous state will be little bit challenging, so which means you will have difficulty in disaster recovery as well. Limited rollback capabilities, as I already said, since you're not controlling the versions of each and every configuration, it is very hard to roll back. Lack of continuous integration and deployment. Yes, for every change you need to manually run those Terraform commands. There is no CI/CD tool involved in pulling your changes and implementing your changes. So these are some of the difficulties that you face if you maintain and run the IAC code, yourself from your local machine. Now, what is GitOps for IAC? So GitOps means we know that the entire, the code will reside inside Git or GitHub. So it can be your source code, it can be your configurations, everything will be now managed in Git. So if you manage everything in Git, so this is known as GitOps, because Git is now acting like a single source of truth, either for your code or your configuration. And every change that you make inside the Git will be reviewed, tracked, it is auditable, and it is easily reproducible because you are maintaining everything inside a single repository, inside a Git repository. So others can see your code, others can review your code. If they find any mistakes or issues with your changes, then they can ask you to change them, then they'll approve those changes. So this is GitOps. So you have everything in Git. Now your changes are easily tracked. Not only that, so in GitOps, basically there will be GitOps operators as well. So where if you make some changes in your Git repository, these changes are read by some more external tools, and they do some other things. For example, we'll talk about Atlantis. So Atlantis, you can take Argo CD. So these are all GitOps operators. So they run somewhere either as standalone application or as a Kubernetes pod. So they are connected to your Git repository. So whenever you make any change, and if a PR is approved, so these tools will read your Git repository and do the work for you. For example, Atlantis, so it can run Terraform commands as soon as you raise a PR with your changes, right? So this is GitOps for IOC, and GitOps for IAC. GitOps for IAC can be implemented in multiple ways. So what here we are trying to achieve is uh, having Git as single source of truth, and we also use for all our operations work. So for example, I have an initial branch called a master with all my initial changes. Now if I want to make some changes, I'll create a new branch, let's say dev, and then make all my changes here, and then raise a PR to merge the changes back to the master. Now at this moment I want this PR to be reviewed and approved. But if it is Terraform, the review process also requires the changes that your code is going to um, due to the actual infrastructure, right? So for example, from EC2 instances count of 3, I changed it to 4. Now a new instance has to be created. But so how do I know whether a new instance will be created, or it is going to create all 4 new instances, or it is going to destroy some existing instances or not? Okay, so I need to have that output in hand in order to approve this PR. Okay, so what I can do is I can have some CI tool like Jenkins. So now what happens is I'll configure Jenkins in such a way that so whenever a PR is opened in this specific repository, okay, so I can write my Jenkins code in such a way that it will clone the branch from where the PR is raised, and then it runs some commands like Terraform format, Terraform validate, and it will also do Terraform plan. Now by looking at the plan, I can understand whether the changes that are implemented are valid or not. Now once I review this Terraform plan, I can approve this PR, and once the PR is approved, again Jenkins pipeline will be triggered, so that will now do Terraform apply. Okay, so this is a kind of GitOps, so where we are using Jenkins to implement your changes and test your changes. There is no manual intervention here, so we are not actually creating the infrastructure from our local machine. But again, there is a drawback here, that is, we need to go to the Jenkins console output to see whether Terraform plan output is successful, or all our Terraform commands are successful or not, right? So other way around is you can ask your Jenkins to create a pull request command saying that Jenkins has successfully ran the Terraform plan, and it can also publish those results, the plan output back to your PR as a pull request command. Okay, so it can add a comment in the pull request. So the reviewer need not leave his screen and go to Jenkins console output to see the result. He can directly see that result directly in the PR window. But again, setting this up is quite complex. So you need to, basically push your outputs back to the GitHub by calling GitHub APIs and all. So that's an extra thing that you need to implement in your Jenkins pipelines. Okay. Now, what is Atlantis and how Atlantis simplifies this Terraform pull request automation? So Atlantis is a tool for collaborating on Terraform projects. It is completely open source, and it is self-hosted tool. You can host it in your local machine or inside any cluster. Um, you know, how it actually works is you create a PR with your changes, and you run some commands on the PR itself. For example, this is the change that I have made, and what I will do is I'll simply say Atlantis plan. I'll myself comment on my PR saying Atlantis plan. So when I just say Atlantis plan, okay, so here is my repository, and Atlantis is running somewhere. It can be in an EC2 instance, or it can be as a container or a pod. It can be anything, but these two are connected through webhook. So whenever I create a PR and comment on the PR, I'll say Atlantis apply. Atlantis plan. Now, since Atlantis is connected to GitHub, so as soon as you raise a PR and comment on the PR, GitHub will trigger the webhook that will notify the Atlantis. Uh, to run the plan for you. Okay, so it will run Terraform plan, but it won't stop here. So it will, it will take this plan output and update your PR as a PR command, which means, once I do Terraform plan or Terraform apply, after some time, you will see, the output directly in the PR window. Okay, you don't have to go to the Atlantis and check its log, because that is already committed back to your pull request. And these are some of the advantages of Atlantis. The first thing is fewer mistakes, because you're not implementing the changes, you are letting Atlantis do that hard work for you. And you'll also get instant audit logs, right? Because it's Git. Everything has to be everything is visible in the Git. So if you raise a PR, that PR, before approval, the reviewer basically sees the Terraform plan output and sees whether this plan is correct or not, or if it is destroying something, you can simply reject that PR as well. Okay, so before actually merging your PR, um, reviewer can see all those changes, right? It is self-hosted and open source, as we already discussed. And this is Atlantis is as simple as you comment on your PR. Here I just commented Atlantis plan. Atlantis has a lot of commands, so Atlantis plan is similar to Terraform plan. As soon as you create a PR and run Atlantis plan, if you comment on your PR, so Atlantis is going to get triggered. Atlantis is going to run Terraform plan for you, and it will automatically publish that Terraform plan output as PR comment. So you can directly see that result here itself. And you can also run Terraform apply. So in this case, Atlantis will run the apply for you, and it is going to comment the output back. In case if you have Terraform outputs, you can see the Terraform outputs results in the same PR window as well. Okay, so which means even before your PR is approved, you can actually create the infrastructure. Only when infrastructure is created, you can approve the PR and then merge it. Atlantis also has some other options as well. One such option is run in require approval mode. So what is the meaning of this is, you know, uh, PR approval before allowing apply to run. So if you enable require approval mode, then how this work is, if you try to apply the changes using Atlantis apply, okay, your Atlantis will reject it because that PR is not approved it, which means for running Atlantis apply or for provisioning infrastructure, you need an approval. That is, PR should be approved, which means by looking at the plan output, the reviewer will approve your PR, then only you will apply the changes. So once the apply is successful, you can basically merge the PR. So this is, you know, probably a life cycle. Okay, so once you do Terraform apply, or once you command Atlantis apply on the PR, so Atlantis is going to run Terraform plan, Terraform apply, and it is going to just show the results in the PR itself. Okay. So how Atlantis works is, as I already said, Atlantis and GitHub are connected via webhook. So whenever you make any change in GitHub, we call this as an event. Like creating a branch is an event, creating a PR is an event, commenting on PR is an event, adding a label is an event. So there are a lot of events. So Atlantis only requires some events like PR comment event or label event. So there are some. So once you enable all those events, so as soon as GitHub knows of that event, let's say I created a PR, okay, it's an event, or I created a comment on a PR, it's an event. So as soon as that event occurs, GitHub will call that webhook URL, which is basically your Atlantis. Now Atlantis gets that ping. Atlantis will clone your GitHub repository into it. It will run plan, apply, uh, depending upon your requirement. And also it is going to command the result back to the PR itself. So this is how Atlantis. So if you look at this setup clearly, closely, it resembles the setup between GitHub and your Jenkins or Jenkins and SonarQube. So all these tools are connected through webhooks, right? Now coming to the differences in traditional approach and GitOps approach. In traditional approach, so basically the user from his local machine will run all Terraform commands to provision infrastructure. Now using GitOps, you don't run anything. Okay. So you simply raise a PR, and the tool that is running on the other side, right? Like Atlantis is now acting like a GitOps operator here. So Atlantis will get that ping, okay, and then it does apply or plan or whatever it is that you define. Okay, and not only this, Atlantis can also work on custom commands as well. So in case, let's say you wanted to run some custom commands, you know, we want Atlantis to run some custom commands. Okay, I'll simply say Atlantis, test. Maybe this is not the supported command in Atlantis, but I want Atlantis to respond to this test command. So once I do Atlantis test, if I comment on the PR, I want Atlantis to do Terraform FNT first, Terraform validate first, or probably run some commands like tflint or whatever. Okay, so which means I can also create my custom workflows, and I can just comment that command right in the PR, right? Yeah, so Atlantis also has a dashboard, so you can just visit the URL of Atlantis, and you will see all the repositories and their current, step, like whether Atlantis is running plan or apply. So that entire events, right? You can see it in the dashboard. If you click on plan or apply, you will see exactly the same output that you see in your local machines, right? Now this is the entire workflow. So you start by creating a pull request with your changes. Now on the PR, you can run Atlantis plan. Okay. Now the Atlantis will run plan and command that result back to the PR. Now the reviewer will have access to that command. Okay. So you can see the entire plan output and then simply can approve the PR. So once the PR is approved, I will now get an option to run Atlantis apply. I'll run Atlantis apply. Atlantis will provision infrastructure and comment those results back to the PR. And once I'm satisfied with the final output, I can simply go ahead and merge my pull request. So this is the end-to-end working of Atlantis. I also have a repository that I created. Okay. So inside this, I have Atlantis deployment to run Atlantis inside EKS. I have a simple Terraform code with some resources. So one is AWS EC2 instance resource and one is random resource. Uh, how many resources to create, like how many, um, um, basically so this resource will basically generate the random UID. So I want to control the number of UIDs that are returned. So I have a count variable here, and the number of instances also I'm controlling through count. And these are provided through variables. So the number of UIDs and instances counts are numbers type that have default value of 1, right? And I have providers block here. So with random and AWS as the required providers. And the other thing is I have output. So I'm reading all the outputs from random UID resource and AWS instance resource. And I have this README updated. So basically we'll be creating our EKS infrastructure from our local machine. So we need to have AWS CLI, kubectl CLI, EKS CTL CLI, and you need to configure your local AWS CLI with your credentials to your AWS account. So for this, I'll be creating, an IAM user with programmatic access, and then I'm going to just run AWS configure in my local machine. So that is going to configure my AWS credentials. After that, I'll also install EKS CTL. So using EKS CTL, I'm basically creating a cluster known as demo in the AP Southern region with 2 nodes to start with, and minimum and maximum are also set here, and the node volume size is set to 8 GB here. And once I'm done with cluster creation, I can just get the cluster, update my local kubectl configuration so that I can talk to my EKS cluster. And here I'll also need load balancer to expose my Atlantis. Okay, so for that I need to set my service type as the load balancer service type. Uh, I'll go to the Atlantis documentation where I'll show you the configurations and the ways to deploy it. Okay. But for provisioning and a load balancer for any service type that is set to load balancer, so I need to have AWS load balancer controller deployed inside EKS. So for that, I need a service account and a Helm chart for deploying AWS load balancer controller, and then I'm installing that load balancer controller. But before that, I also need to have an OIDC provider. Okay, so you can click on these links to understand more on this requirement. So I have included links for everything. So you can see how to deploy AWS controller, what are your initial requirements, like service accounts and all, you can clearly see here. And also remember here, I'm including my AWS account number. So in this case, in your case, you should include your own AWS account number and do the changes according to your AWS account number. Okay. So once you have the OIDC, you can install AWS Cloud Load Balancer controller, and it will be installed basically in kube system namespace. You can also get the deployment. Okay, so once you're done with this entire demo, you can just delete the cluster. So this is a command for deletion of the cluster, but you still need to run it at the end. Okay, so now let's go to the Atlantis. So the Atlantis URL is runatlantis.io. So this is the home page for Atlantis. You can just click on get started. So here Atlantis also gives you something known as test drive. So in case if you want to test everything locally. Okay, but the problem is you are running Atlantis on your local machine and you have GitHub on public domain, right? So how does GitHub will call your local IP address? It's not possible. That's why when you're setting it up via testing locally or test drive, I think it is going to uh, create install ngrok ngrok. So this will basically give you a public DNS. Okay, so that your GitHub will call that public DNS, and that public DNS basically will call your local IP address. So this setup is not required. Okay, so we'll be doing it inside EKS, and we'll be exposing it through AWS load balancer. That's the reason why we installed AWS cloud load balancer. Okay. Anyways, we are going to show see everything in the demo. Now coming to the docs, you can see docs for installing Atlantis, configuring Atlantis, and using Atlantis. So installation includes some requirements. So if you look at the requirements, you need GitHub and some GitHub tokens. So I'll come to it later. Okay, so once you have the code in GitHub, you need to have access credentials for your GitHub. Okay, so in our case, what I'll do is I'll create personal access token. So that is also given here for GitHub. So you need to create a personal access token. Okay. Otherwise, how do Atlantis will uh, uh, talk to your GitHub or make a comment on the PR, right? Without proper credentials, right? It can't do anything. So that's the reason we will create a personal access token with limited scope. Again, I'm going to show that as well. Now creating a webhook secret. So basically GitHub can talk to Atlantis, right? Through a webhook. So we'll also include an extra layer of protection by adding a secret value here. Okay, so this is not Kubernetes secret. So this is a secret value that your GitHub will send to your Atlantis. Okay, so now Atlantis will only accept the webhook if the webhook includes this secret, right? Because anyone can send webhooks to Atlantis, but I want GitHub to include a specific secret so that Atlantis will only respond to such webhooks that include that secret value. Okay, now we can deploy Atlantis. So for deployment, there are multiple options. You can basically deploy it using Kubernetes Helm chart or deploy it in Docker and all. But I don't want to do this with Helm. uh, uh, to complicate it, I'll just get the Kubernetes manifest file and I'll try to deploy it. So Kubernetes manifest files are here. So you can deploy Atlantis both as deployment or stateful set. I don't want to retain the state. I'll be using deployment here. If you look at the deployment, oh, so not this. Let me go to the bottom here. So here is a manifest file for the stateful set, and here it's for deployment. It's a simple deployment which will deploy one replica of Atlantis. So this is the Atlantis image, and Atlantis also needs to, uh, you know, allow list certain URLs. For example, I want Atlantis to only respond to webhooks if they are coming from my internal organization or from my own account, something like that, right? And then I need to provide the GitHub user, GitHub personal access token, and a webhook secret token. And some configurations related to GitLab, these are all not required, so you can simply delete them. Uh, yeah, so you can delete them till here. Atlantis port is 4141 and some health checks. Okay, now this is a service. By default, it is exposed as cluster IP, but we'll change it to the load balancer, right? So this one. Okay. Yeah, so this is the requirement. Okay, so this is how you um, you know, install Atlantis, and then configure the webhook. So we need to go to GitHub and configure the webhook. So you can also see what all the events that you need to check, so that GitHub will only send these events to Atlantis, right? So we'll also see this. And provider credentials, I want Atlantis to provision the infrastructure, right? I want Atlantis to provision the infrastructure in my AWS account. Okay, so basically Atlantis means, let's assume it is Terraform. So Terraform requires credentials to my AWS account. So there are multiple ways I can provide such credentials to my Atlantis. So in case if Atlantis is running as a pod, I can use the concept of IRSA roles or IAM role for service account, where I'll create an IAM role and give permissions to that IAM role, and I'll attach that IAM role to a service account, and the pod can mount the service account token. So now the pod has the proper credentials to create AWS resources on my behalf. Or else, we know that AWS credentials are a couple of them, like AWS access key and AWS access key and secret access key. So what I can do is, inside your Atlantis pod, I can actually mount them as environment variables, right? So I can also, do that. So for environment variables, uh, I can just click on, yeah, this link. So this will redirect to AWS provider Terraform documentation. So you can provide such credentials in the form of environment variables. So environment variables means it should be AWS access key ID and AWS secret access key. And AWS reason can also be included. So this is how I configure. Okay, so you don't have to worry about these configurations because I already gave inside the repo. So it is inside this folder called Atlantis deployment. So ignore this IAM policy.json. Just click on this deployment. See, I'm running the latest version of Atlantis. Okay. So if you see, I have an environment that is added for injecting AWS access key and secret access key ID. And these two are being read from a secret. So I will be creating that secret. So if I go back to my repository, in the README file, you will see that I'm creating a secret. Okay, um, called AWS credentials of type generic secret. So where I'm providing AWS access key ID and secret access key. Okay, so this is a secret I'm going to use so that Atlantis can get proper credentials to talk to AWS, right? And also I'm providing the default region, that is AP South one. Okay, so there are some configurations that we need to add. Okay, if you go through the documentation, you'll understand. So these are the configurations. Okay, and also if you want to configure Atlantis, anyways, we will see. in the coming session, how to configure Atlantis. So here there is something known as server-side configuration, and you will find all the configurations for Atlantis. You can control Atlantis behavior here. Okay, so you can provide these basically configurations in the form of a flag or in the form of an environment variable. So what I did is I provided an environment variable called disable auto plan. So what is the meaning of disable auto plan is, so initially when you create a PR in the repo, Atlantis by default will run Terraform plan. Okay, so even without anyone's initial comment on the PR, that is even before I go and comment Atlantis plan on the PR, Atlantis is going to run plan first. So I disabled it using this. Okay, and also Atlantis allow repo list. Okay, you can see I'm allowing the webhooks from my own GitHub account. That's the reason I have my uh, user account name here. And Atlantis GH user should be there, and GH token, that is GitHub webhook token, and that is also read from a secret. Okay, along with the webhook secret. Okay, so that is also given here. So here I'm providing my webhook secret and GitHub personal access token. I'm redacting it to a file and creating a secret from both these files, and I'm calling that secret as Atlantis VCS. So you can also see I'm reading both GitHub token and webhook secret from the same Atlantis VCS secret. So here personal access token, I'll show you how to create in Git. And this webhook secret should be of random string of greater than 24 characters. Again, it's up to you which 24 characters to use, or you can auto generate, right? And then I'll go and apply the deployment file. And this deployment file has a service here. So this service here, I'm still using cluster IP. Okay, so whatever is there inside in the official documentation, but here I created an ingress resource. So if you have an ingress resource, and if you have AWS Cloud Load Balancer controller already deployed, you'll basically get ALB for this. Okay, so here what I'm saying is I'm trying to create an ingress object. The name of the ingress object is Atlantis. So it is an internet facing ALB, right? And the ingress class name is ALB. Okay, so the path is slash. So once I hit slash, right, it should go to the service called Atlantis on port 80. You can also see the service here. The service name is Atlantis, and the incoming port or port is 80. Okay, so this is the basic ingress that I'll be deploying as well. Okay.